R. Really? So JavaScript. Who would have thought that you could get a bunch of people together in any city to talk about JavaScript? How really unlikely. It has become the world's most popular programming language. There are more of you writing in JavaScript today than any other programming language. It's running on more systems than anything else, and it's not just in the browser, it's all over the place. At the same time, it's the world's most unpopular programming language. If you ask any group of programmers, what language do you hate the most? By far, the most common answer is going to be JavaScript. Probably pretty equally between people who use the language and people who don't. And it's all because of this guy. This is Brendan Eich. He was hired at Netscape to make the Netscape browser work like HyperCard. And the approach that he took was really audacious. He started with Java because they told him it had to look like Java, took the best parts of Scheme and the best parts of Self, which were two languages which had no commercial success, but he poached features from them and put them together into a new language called LiveScript. Never told anybody exactly what he had done and what the consequences of his design decisions were, but they were amazing. For reasons we don't have time to discuss today, it was renamed as JavaScript in order to deceive the world as to the importance of the language, and that very nearly succeeded. It then became, one of the problems with the word JavaScript, beyond the obvious ones, is that it's not open. It's a proprietary trademark, which now belongs to Oracle Corporation. So, it's the language of the open systems, but it is not itself an open name. So it may have become generic by now. It may have been aspirined or Kleenexed or Xeroxed, but just in case it hasn't, we can always call it ECMAScript, which is another synonym for the same silly language. Now, I don't know if you remember the .com bubble. Anybody alive when that was going on? The web was a big disappointment as an application delivery system. Page replacement was obviously too expensive. Java applets failed. The Java community doesn't like to remember this, but Java had the first shot at being the language of the internet, fell flat on its face hard, one of the most amazing, significant, profound failures in the history of software. Not well remembered, but in fact it happened. But JavaScript was there too, but nobody understood JavaScript at the time. So it was pretty clear that the web failed as an application delivery system. The consensus at the time, this was around 2000, was that the web was dead, that it was going to be replaced similar to the way that HyperCard had been replaced, that things are great for a while and then something will come and go better. So the future was obviously not document retrieval, it was going to be distributed programming, what some people at the time were calling the X-Internet. One of the proponents of that was George Colony, who was the CEO of Forrester Research. And he wrote on their website, "Another software technology will come along and kill off the web, and the judgment day will arrive very soon in the next 2 to 3 years." He was right, and he was also not completely right, but he was influential. By the way, this is not on the Forrester site anymore, but you can find it on archive.org, so it's still out there. So Microsoft heard this and believed it. Okay, the web's gone just like everything else goes away, so we'll start working on everything else. So they disbanded the IE team because the web was finished and put them to work on Avalon and other things which are going to be more focused at the X-Internet. And then were blindsided by the web a second time when Ajax came up in 2005. With that, JavaScript got a rare second chance. In a perfect world, JavaScript would have died as a proprietary language with Netscape when Netscape died. But it didn't. It got a second chance. And Ajax succeeded because of the goodness in JavaScript. If JavaScript had been as crappy as everybody had thought it was from the beginning, Ajax could not possibly have succeeded. But it did succeed because of that goodness. So despite that, a lot of people hate JavaScript. And there may be some good reasons and some bad reasons. The good reasons are that it has bad parts. It has a lot of really bad parts. Some of the worst ideas in the history of programming languages can be found in JavaScript. And this is a direct consequence of the language having been designed in about 10 days. I challenge any language designer. It's not engineering, it's a quick-fire challenge. It's a stunt. And it's amazing that he managed to get as much goodness into the language given the amount of time he had to think about it. Some people hate JavaScript because the DOM is so awful. And that's a good reason to hate the DOM. It's not a good reason to hate JavaScript. A lot of people hate JavaScript because it isn't C or C# or C++ or Python or Ruby, because it isn't a language that they know and like. What can you do about that? And there's some people who hate JavaScript because it didn't die. But it had good reasons to not die. On the other hand, there are good reasons to like JavaScript. It has good parts, some of the best parts ever incorporated in a programming language, and the combination of those parts is absolutely amazing. What JavaScript is, fundamentally, is a functional language with dynamic objects and familiar syntax. And if that's all JavaScript is, it's an amazing accomplishment, and that's why it works. It scales from beginners to masters, which is very rare. It's hard to make a language which is suitable for either of those extremes, but JavaScript meets those and everybody in the middle at the same time. That's, again, an amazing thing. JavaScript is especially effective in event-driven applications, which is a lot of what we're doing. Functions with callbacks, that's a very easy thing to express in this language, and it is the right way to write interactive applications. Programs in JavaScript can be significantly smaller than equivalent programs in other languages, but only if you think in JavaScript. You can come to JavaScript thinking in Java or thinking in Python, and you can actually make a lot of progress. But you're not going to get the great efficiencies that this language provides you unless you can think in JavaScript. The language is now finding success in lots of non-browser venues. It's been in desktop applications for a long time. For example, most of the Adobe suite has JavaScript built into it. It's built into operating systems now. There are widget systems in both Windows and Macintosh that use JavaScript. It's in databases now. Like CouchDB lets you run JavaScript in the database. Amazing. It's finding a lot of use in mobile applications. It's finding its way into consumer electronics. There are now television sets with JavaScript in them. And perhaps the most interesting thing is we're now in servers. JavaScript was in the first commercial web server. I don't know if anybody remembers that. The original Netscape Livewire server had server-side JavaScript. Sun eventually got control of that project and killed it off, replaced it with Java, and that's where J2EE came from. But server-side JavaScript is back. There's a lot of really interesting work going in there. I'm very encouraged by that. So JavaScript obviously has a lot of bad parts, so it constantly raises the question, can we make JavaScript a better language? There are certainly good reasons to want to do that. The difficulty is the web itself. Once something gets into the web, it's really hard to change it. In particular, there are older browsers out there that will continue to run, so you can have a new language or new versions of language, but the old browsers won't understand it, and so that introduces a lot of pain and misery for web developers. I found that the most effective way to make JavaScript a better language is to simply remove the bad parts. And that's a difficult thing for ECMA to do. We can't easily remove bad parts from the standard because the bad parts are not useless parts. They're just unnecessary and dangerous. And because they're unnecessary and dangerous, they're widely used all over the web because that's sort of the way the web works. And you could argue that the programs that are written using those bad features deserve to be broken, but at ECMA we believe that we should try to not break the web, and so we can't take those things out. But you can. As developers, you get to choose what subset of the language you want to use. So simply by saying, I will not use the bad parts, you get to use a better language. And that's a great thing. And to help you do that, I wrote a program called JSLint, which will read your programs for you and painfully point out the cases where you're using the bad parts. I highly recommend you use JSLint. Part of the bargain that you have to make with JSLint is that you have to avoid forms that are difficult to distinguish from common errors, which is something you should be doing anyway. You don't want to be writing programs that can't be easily distinguished from bugs. The less your program looks like a bug, probably the more likely it isn't buggy. So if you can do that, JSLint can help you write much better programs. So there are, the ECMAScript committee, TC39, is now working on a project called Harmony, which could become the next edition of the language. It's difficult to talk about what's going to be in the next edition. It's irresponsible for a standards body to pre-announce what's going to be in a standard before the standard's been ratified, because you don't know if it's actually going to ever happen. There are some things that we're looking at which are likely to be put in, and there are other things that we're debating, so we'll go through some of that. First, we'd like to correct the block scope problem. As you may have discovered, JavaScript syntax appears to support block scope, but in fact it doesn't. So a block in JavaScript is not scoped, only functions have scope. So a var which is declared anywhere is visible everywhere within a function. And it turns out you don't need block scope in order to write good programs, so that's good. But if you think a language has block scope and it doesn't, then that's a source of errors, and we'd like to fix that. So we'll probably be adding a new let statement and a const statement, which will replace the current var statement, and those will respect blocks. We're looking at better support for functions with a variable number of arguments. Right now we've got the arguments array, which never worked right and has some really, really bad implications. It's terrible for performance. So we want to get rid of that and add some new syntax which will let you deal with variable number of parameters in a much nicer way. So you don't have to splice the parameters anymore to get the stuff you want. You can just ask for it and get it. Now the problem with both of those things is that they require new syntax. And new syntax is completely useless if you must support the older browsers. New syntax is a syntax error on browsers that don't recognize it. You can't if around syntax. It means the whole thing doesn't run. And where I work, if we get a syntax error on the page, we don't get paid. So we can't tolerate that. So the problem, the major problem is IE6. IE6 is fading very slowly. 5 years ago, I predicted that it would take 5 years for IE6 to fade away. It's still here. Its market share has diminished some since then, but it's still hanging on, and it looks like it's going to be hanging on for a lot longer. There are more obsolete versions, or more obsolete IE users out there than users of Opera, Safari, and Chrome combined. So if you're making decisions about which browsers do we want to support, it's really hard to say we're going to support Opera and Chrome and Safari and not support IE6. But IE6 comes with this terrible backward compatibility burden. IE6 is hanging on basically because we are allowing it to hang on. Because we've done such a good job of supporting it and keeping it going, it's going. And so we can talk about changing the language and adding new features and removing the bad features and correcting all that stuff, but it's just a waste of time as long as IE6 still has dominant market share. So that's why I come to you and say that IE6 must die. We need to get rid of it. It's causing us a lot of pain, and we'll get back to this in a moment. So one of the most reported bugs, or the most reported bug in JavaScript, is a variation of the problem that 0.1 plus 0.2 is not exactly equal to 0.3, which would only be a problem if you're living on a planet where people use the decimal system, and we are on one of those planets. This is obviously wrong. It's wrong because we are using the IEEE binary floating point standard. And this is not just wrong in JavaScript, it's wrong in every language that uses it, which is basically every language that was designed over the last 20 years. It was a bad design choice, it was a popular design choice, but we need to get rid of it. We had considered replacing JavaScript has one number type, And that turns out to be a huge advantage. Most languages come with a lot of number types, basically a callback to assembly language, and most of them work wrong. Like most integers, it's possible to add 2 positive numbers and get a negative result. That's insane. How could anybody have ever thought, any engineer, any mathematician think that's a good idea? JavaScript does not have that defect, so hooray for JavaScript. IEEE proposed another standard for a decimal floating point type, which solves this problem, so that's good. But in current implementations, it comes with a performance penalty of hundreds. So we couldn't convince any of the browser makers to implement it, so we had to reject it. The reason we were looking at that format was IBM was saying, you have to use that format. We're hoping IBM will become more reasonable now that we can consider other decimal formats and we can go on with something better. There's a lot of interest in making JavaScript a better target for implementation. It has become the virtual language of the web. We always thought it would be the Java VM or maybe the CLR, but it turns out JavaScript is the common runtime. So there's a lot of interest in adding new features to the language to make it easier to compile other languages into JavaScript. For example, putting in ints so that the errors that are in other languages can be more easily reproduced in JavaScript programs. We're probably not going to do that. Our first mission has to be to the web and to the users of the language as the language. But we still feel a lot of pressure there. There's also a lot of interest in an intermediate representation. The theory being that if we could, right now in JavaScript you send the source file to the browser, it gets compiled and executed on the browser. If we could send some intermediate representation, then we don't have to pay for the compilation step and everything should go faster. Java made it really clear that that just isn't true. I mean, Java does that, and the startup time for Java applications is appallingly slow. So JavaScript actually got that right, and I think we'll probably continue to get that right. Another reason for having an intermediate representation, for example, abstract parse trees, would be that you'd have a version of the program which is more easily manipulatable, and there might be some value in that, particularly if we used it to create a macro system. We're under a lot of pressure to add new features to the language, but a lot of those features would be made unnecessary if we had macros in the language. So essentially you could define your own language in the language, and then the committee doesn't have to worry about that stuff anymore. And one way that macros might work is by working on the syntax trees. So that's something we're looking at. We get a lot of requests for having threads, and I'm pretty confident we will never do that because threads are evil. Like many evils, they're sometimes a necessary evil, and so in operating systems, at the system level, it makes sense maybe to have threads in the system. At the application level, it makes no sense at all. You should never have threads in the application level. And I think one of the design errors of Java was that it's trying to be a system language and an application language at the same time, and so threads leaked into the application level where they're evil. One feature I'd like to get in is tail calls, which is the optimization of the form where you return the result of calling a function. It turns into a go-to, basically. So it can make recursion a lot faster, and it can introduce new versions or new programming models like the continuation passing style, which is a really elegant and wonderful way to write programs. It comes with a terrible cost, though. And the terrible cost is that debugging becomes more difficult because we short-circuit these calls, turning them into jumps, and so the call stack is incomplete. So you can't look at how you got here. You know you were here, then somehow you got there, and there's no record that the debugger can see that shows how you got from there to there. That's a huge trade-off, and we haven't figured out how to resolve that yet. There's a lot of interest in making JavaScript more like other languages. And my advice to people who want to be writing in other languages is write in those languages. I mean, there's no reason why you shouldn't be able to do that. We shouldn't have to make this one assume all of the features of every other language. I think that's an unfair burden to put on any language. There's a lot of interest in exciting new features, but it's really easy to go off the rails with that kind of stuff. So in reviewing those, my personal criteria for improvements that are worth considering are changes to the language which significantly increase the readability of programs. If we can read programs and understand what they're doing better than we can now, then that's maybe a worthwhile thing to do. Also, if we can significantly increase the productivity of the programmer, so that something that you'd now do in 10 lines, you can now do in 1 line, go, yeah, that kind of amplification, I like that. So, taking something you can do in 10 lines and doing it in 9 lines, I don't think that's a win. I think that's probably not worth doing. The most important thing, and possibly the only thing I think we should be considering, is security. Because the biggest problem in the browser platform is its susceptibility to cross-site scripting attacks. There is no more urgent thing to work on than that. So cross-site scripting attack means that an attacker can get some script onto your page, and then he essentially gets control of everything. So what exactly does he get to do? First off, the attacker can request additional scripts from any server in the world. There's a same origin policy in the browser. It does not restrict his ability to go anywhere in the world to get more script. It takes only a tiny amount of JavaScript or a tiny amount of HTML, and you can then load megabytes of additional programming that can come in and complete the attack. Once it gets a foothold, it can obtain all the additional script it needs. The attacker can read the document. The attacker can see everything the user can see, and also things the user can't see. It can see all of the source. It can see all the comments. It can see the hidden fields and the values in those fields. It sees everything that was delivered to the browser. The attacker can make requests of your server. Now, if you're smart, your server is looking for secret tokens of authorization which say, this is an authentic request, and I will only respond to these things. But the attacker has access to those same tokens. There is no way you can distinguish honest requests from evil requests. You cannot tell. If you're using SSL, and you should, he gets access to your secure channel. Your server cannot detect that the request did not originate with your application. If your server accepts SQL queries, then you have given the attacker access to your database. Now, if you're constructing SQL queries using information that you obtained from the browser, you probably gave him access to the database. That's because SQL was optimized for SQL injection attacks. The attacker has control over the display and can request additional information from the user. One common technique when an important request comes from the server, you ask the user, or it comes from the browser, you ask the user to enter their password on the assumption that the attacker doesn't know the user's password. But the attacker has control over the display, so the attacker can ask the user, what's your password? And the user will tell him. Particularly if you have a site which routinely asks the user for the password, what you're really doing is training the user to give up the password anytime anybody asks, because that's just how it works. So it makes it really easy for the attacker to get at that. Now, browsers today are coming with a lot of anti-phishing Chrome, which is a really nice thing, except most users don't pay any attention to it. But if they are paying attention to it, that Chrome will say, this is a legitimate request, give it up. The attacker can then send all the information it has obtained from scanning the page, from querying the user, and from attacking your database, and send it to any server in the world. Again, the same origin policy does not restrict his ability to distribute this ill-gotten information. The browser does not prevent any of these things. Now, I'm not talking about bugs. Obviously, the web is famous for its bugs, and there have been lots of security mishaps, but I'm not talking about that. I'm talking about standards. The problems that I'm talking about are a direct consequence of the web standards. Web standards require these weaknesses. If you do not have these vulnerabilities in your browser, you are not web standards compliant. The web standards are wrong and have to be fixed. The consequences of an attack are horrible. There can be harm to customers, there can be a loss of trust, there can be legal liabilities, in some cases there can be criminal liabilities. And it's just waiting. Everybody here is susceptible to these attacks, and it's just a matter of time before you get clobbered. Cross-site scripting attacks were invented in 1995. They were enabled by the Netscape 2 browser, have been copied into every browser since then. We have made no progress on the fundamental problems in 14 years, and this is intolerable. We've got to change this. So why do we have XSS? What are the causes of it? In any complicated problem, you can't identify a single cause, but these are the major contributors. First, the web stack is way too complicated. There are too many languages like HTTP, HTML, CSS, JavaScript, URLs, all with their own encoding, commenting, escapement conventions. They can all be nested inside of each other. As a consequence, it's really, really hard to look at a piece of text and determine if it's benign or not. In addition, the browsers do heroic things to try to make sense of malformed content. They did that early on to gain market share so that incompetent webmasters would not make them look bad. But today, those features really benefit nobody except the bad guys, but they're still there and are now being institutionalized in HTML5. We have dependence on template-based web frameworks that are optimized for XSS injection. All of the Ps, ASP, JSP, PHP, all these templating systems make it really easy to insert evil script and send it back. It's possible to use all of these frameworks correctly, but it's much easier to use them incorrectly, and so that's the way they're often used. The JavaScript global object gives every scrap of script the same powerful set of capabilities. So all script is the same. Now, as bad as the browser is at security, it is a vast improvement over everything else. It's way better than the desktop in terms of managing the security of the user. The problem with the browser is that it does not anticipate that there are multiple interests on the page, more interests than the user and the site. And that is the root cause of the cross-site scripting problem. So fundamentally, cross-site scripting is a confusion of interests. It's dangerous. It needs to be corrected now. Solving the XSS problem should be our #1 priority in looking at web standards. We cannot tolerate web standards that make things worse. So mashups are a self-inflicted cross-site scripting attack. A mashup is an application made up of programs representing multiple interests that cooperate together in order to create some benefit for the user. It's the most interesting thing we've seen in software development, I think, in 20 years. But it's not safe yet because of the cross-site scripting problem. Turns out advertising is a mashup. And advertising is the way the web pays for itself. But advertising is another self-inflicted cross-site scripting attack. And we've seen lots of cases where problems in the ad system have caused sites to get attacked. We have made a little bit of progress on the mashup problem with the secure JavaScript subsets. There are a number of these. Two of them are Kaha, which is a Google system. It's being used heavily at Yahoo, and my own AdSafe. They're both based on the same theory, but take different approaches to achieving it. Kaha translates JavaScript into JavaScript, adding stuff which adds indirection to access of global variables, inserts runtime checks to make sure that this doesn't get bound to the global object, things like that. Unfortunately, that causes a lot of inconvenience to the developer and can make the code run more slowly. AdSafe is a static verifier. It's built into JSLint. It enforces that you're using a smaller subset of the language, which excludes use of global variables, excludes use of this, and limits use of bracket notation. So there's some inconvenience there, but there's no runtime penalty. Both work. Both make it possible to add third-party code to any page. and have confidence that that third-party code cannot get out of control and do all of the things that I just described. Both have informed ECMAScript 5th edition strict mode, which ECMAScript 5th edition was approved last November. Features of it are starting to appear in the newer browsers now. Hopefully, by the end of the year, we should start seeing it completely implemented. ES5 strict makes it possible to have static verification of third-party code without over-constraining the programming model. So basically, we get the best of Caja and AdSafe, where we can do static validation on some guest code, but allow it to use a much larger fragment of the language. There's still a lot of work left to do. ES5 strict does not protect pages from cross-site scripting injection, so that's still a vulnerability. We still need to fix that. It can protect the page from widgets, but it cannot protect the widgets from the page. So that means you can't put a banking widget or an ad onto a potentially dangerous page. So that's still a problem. But it is an important step toward a programming model in which multiple interests can cooperate for the user's benefit without compromising each other or the user. So again, IE6 must die because we can't use any of this. ES5 strict mode doesn't do us any good if people are still running IE6 because it will never have ES5 on it. So we have to get rid of IE6. The right thing to do would be to have everybody look at what browser is coming to them, and if it's IE6, send them to a page saying, here are 5 new browsers that you can download and they're free. Go and do one of those and come back. Right now, nobody is doing that because basically Google doesn't want to be sending its IE6 users to Bing, and Amazon doesn't want to be sending them to Barnes & Noble. So we all have to agree to do it at the same time. And I propose the day we do that is 30 days after ES5 is complete in all 5 browsers. Okay, that day is not far away, and when that day happens, IE6 dies. Yeah, thank you. Now, ES5 strict does not solve the XSS problem. That's still there. It only works for good guy code, code that we invited onto the page. Code that we did not invite is still there and is still dangerous. So we still need to fix that. And we're looking at doing things in the next edition of ECMAScript that will solve that, getting rid of the global object entirely, stuff like that. But we also have to fix the DOM. Fixing ECMAScript and not fixing the DOM doesn't accomplish anything. So I don't want to burst anybody's bubbles, but the DOM is an awful API. Has anyone discovered that yet? It inflicts tremendous pain on developers, and it enables XSS attacks. It's bad. It's got to go. So that brings us to HTML5. HTML5 is a big step in the wrong direction. There's a lot of stuff in HTML5, but security was not, solving the cross-site scripting problem was not one of the goals of HTML5. They did not accomplish it. I think instead they make matters significantly worse. And they make things worse in 3 ways. First, HTML5 is complicated. Complexity is the enemy of security. They significantly increase the size of the attack surface, which is going to make it even easier now for the evildoers to hide their stuff and get it in there. Second, when the attackers are in there, they get more capabilities because they get to take advantage of all the new stuff that HTML5 provides, which cannot be restricted from the attackers. And so they get access to your local database. They now have sockets. They now have inter-process communication. They can do a lot more bad stuff than they used to be able to do. Third, HTML5 is going to take a long time to complete because it's so bloated and grotesquely big. So if the solution to this problem has to wait till HTML6, how many years do we have to wait before we can start work on that? So I think we need to do a reset on HTML5. I recommend that we throw the current HTML5 proposal out and start over from scratch. We start with a new charter which makes the timely solution of the XSS problem the highest priority. And the old HTML5 set can be mined for good ideas as long as they do not undermine the prime objective. So my proposal for the next browser standard is that it have two modes in it. First, the compatibility mode, which contains HTML4 and ECMAScript 5, and that's there to support the old applications so that we can have continuity on the web. More importantly, it's got a new opt-in safe mode that has a new HTML language, which has ECMAScript 6 or 7 or whatever the next number turns out to be, and a new DOM. And I recommend that the new DOM should look like an AJAX library, because the old DOM doesn't really work. It's at the wrong level of abstraction. AJAX libraries are wonderful. The current AJAX libraries were not designed for capability security, but I think we can take the things we've learned from the AJAX libraries and make one that's good, easy to use, powerful, expressive, and safe. Now, a lot of people despair when you talk about security because nothing has ever worked. There's security by inconvenience, which you see at the airport, where they queue us like cattle, and it's provably inadequate. It does not work, but they make us take our shoes off anyway because they have to have the appearance that they're doing something. That turns out doesn't work in computer systems. We've seen security by obscurity, which doesn't work. We've seen confusion of identity, that if somehow we know who everybody is, then we can make good decisions about security. That turns out not to work. So we're reduced to security by vigilance, which means you have to be aware of every potential thing that can go wrong and actively work against that. Now, the corpus of things that can go wrong in the browser platform is way too big for developers to manage. We're constantly learning new things that are wrong with the browser, and expecting everybody to stay current is just impossible. So we've gone to specializations, and now we have security specialists and the developers. But that doesn't work either because it's too difficult, because now the developers are not responsible for security, someone else is, and it just doesn't work. It turns out everybody needs to be responsible for security, but in order for that to work, the whole process has to get simpler. The good news is that I think security can fall out of good software design. It turns out really good software is also secure software. And if security becomes part of your design model, then it's a lot easier to manage. So I'm going to share with you a model of computer security based on information hiding. Information hiding means need to know. I highly recommend that you go to Yahoo and Google for this paper. David Parnas on the criteria to be used in decomposing systems into modules. It's an old paper, it's from '72, it's one of the software engineering classics. You really need to read this paper. Parts of it are dated. For example, he says that you shouldn't do flowcharting. When he wrote the paper, everybody did flowcharting. That was the way we were told to design software. We don't do it today because of this paper. So the things in this paper that are dated are because the paper was so good. So you need to read that. Taking the stuff that Parnas suggests and taking it forward, a reference to an object or a reference to a function becomes a capability, the right to interact with that function or object, and that becomes the basis of security. So now we're not just doing information hiding, we're doing capability hiding and distributing capabilities on a need-to-do basis. So in an object capability system, which is what we're evolving ECMAScript into, there are exactly 3 ways to obtain a reference: by creation, by construction, and by introduction. So by creation means that if a function creates an object, it gets a reference to that object, and that's just necessary. Construction means that an object may be endowed by its constructor with references. This could include references in the constructor's context and inherited references. And then 3, the interesting one, is by introduction. So here we've got 3 functions, A, B, and C. A has references to B and C do not. But it's in A's interest for B to be able to call C. So A does an introduction. A calls B, passing it as a parameter, a reference to C. And when that call completes, B now has the ability to call C. It has the capability to call C. So that's why the style of security is called capability security. This is really simple stuff. I mean, you do this stuff all the time. This is what happens with callbacks. This is what happens when you store a function into an object. It turns out you can build secure systems out of this stuff if you just put some constraints on it. If references can be obtained by creation, construction, and introduction, then you may have a capability-safe system. And if references can be obtained in any other way, you do not have a safe system, and that's where we are today. And that's why cross-site scripting attacks happen. So ECMAScript is being transformed into an object capability language. We made some important steps toward that with ES5 strict. I expect we'll do even better, eventually removing the global object, which is the primary source of capability leakage, remove that from the language. And we must also transform the browser into an object capability system. I believe that we can do that in our lifetimes. I think we could even do that before the decade is out. I don't think it's all that hard. We just need to make it our first priority. For more information on the object capability programming model, I highly recommend Mark Stiegler's talk. They gave it at Google last month. You can find it at YouTube, The Lazy Programmer's Guide to Secure Computing. Really, really good talk. In conclusion, the web is important enough to fix. HTML5 does not fix the web. I think it makes it worse. We need to reset HTML5 and start over. Thank you and good night. So are we doing questions? Can we do questions? Yeah? Okay. Yes?
So I'm interested in what you're saying about trying to solve XSS, but you seem to be kind of putting two issues together. There's, in a mashup, you have code and resources from multiple sources, multiple interests, and you want to shelter them from each other so they can't interfere. That's a very noble goal. But as somebody who professionally broke into web apps for 8 years, I can tell you the main way we get in is through input validation. We inject code in, and so we are in the interest of the application. So doing things like removing the global object or this kind of sequestering, it doesn't matter. We get around.
No, it does matter. In the capability model, you could sneak some new text in there, but that text, each of those pieces of text is going to be a separate compilation unit, will not have access to the global object. So if anything could cause it to run, it'll run, but it cannot communicate with anything else on the page.
So, but a lot of times what cross-site scripting attacks can do is not necessarily steal information from the page. For example, you could use making image requests and on error and on load to actually port scan internal networks.
Right, I'm saying it doesn't get access to those because those are on the global object, it can't see them.
So what would be the model of saying this snippet or this compilation unit, how do you...
I'm saying all compilation units, nothing has access to the global environment. The page can then explicitly introduce each of the compilation units that it wants to have access to those capabilities. But nothing gets those capabilities by default. And if there's code on the page that the page is unaware of, it doesn't have the capability to give it an introduction. So that page is necessarily isolated, or that code is isolated, cannot cause any damage. Yes?
To follow up on that a little bit, it seems like it'd be tricky to reconcile with having generic code like an XML HTTP request that you can use to make a request against any string URL that's on the current domain. So if that got passed, if you got passed reference to that, you'd be able to access the entire website.
Right, so one of the capabilities in the system is going to have to be the ability to communicate and be able to further constrain what you can communicate with. So having all code instantly being able to communicate globally, that's probably a capability we need to shut down. Anybody else? Yeah.
Yeah, what's the real likelihood that HTML5 would get reset?
It's really hard to say. The HTML5 committee is behaving as though it's a done deal. W3C appears to be powerless to inject any management responsibility or discipline on the process. So there's some view which says it's doomed to succeed. The thing that could derail it is if this community, if the web community stands up and says, no, this is not responsive to our problems, we need something better. I think W3C would listen to that. Yes?
As far as the features that people are looking for, you mentioned variadic functions. Has there been any support for method missing like in Ruby?
Yeah, we are looking very carefully at that. That turns out to be a useful capability pattern, that you have an object that wants to be able to relay requests, filtering some and passing through others, and so having that kind of mechanism is going to be very important. All right, well, thank you very much.